In this video, we learn how to solve Bernoulli's equation. A Bernoulli equation is a first-order nonlinear differential equation of the form y prime plus p of t y is equal to k of t y exponent n. So now what makes this equation unique from the first-order linear differential equation is that we have the k of t term being multiplied by y exponent n. So here we are saying that n should not be equal to 0 or 1, because if n is equal to 0 or 1, then you have the equation to be the linear first order differential equation, and so here we expect n not to be equal to 0 or 1. So here p and q are continuous functions on the interval of discussion, and n is a real number. We first divide the equation by yn. So after dividing through this equation by yn, we're going to have this equation. Then we are going to let y exponent 1 minus n to be equal to z. Then we now differentiate z with respect to x, right? So we move the exponent down, so that will be 1 minus n. Then we decrease this exponent by 1, so we are going to have 1 minus n minus 1, which is going to be minus n. Then we now differentiate y, so that will be y prime, because we are using the chain rule here, right? Then our next step is to find y prime from this relation, right? So you're going to have y prime given below. From here, we now substitute y prime into this given differential equation. So after substituting y prime into this equation, our equation will reduce to this form. Now, as you can see, this guy is now a first order linear differential equation. So here, where z is our dependent variable and t is our independent variable, then we can use the method of integrating factors to solve our resulting equation. For our first question, we have to solve the IVP. Y prime is equal to minus 113y plus et y exponent 4 with the initial condition y of 0 is equal to 2. So we first have to write this guy in the form of y prime plus p of t y is equal to q of t y exponent n. So now let's do this and see what we are going to have. So we need to send this guy to the left hand side, and so we are going to have y prime plus 113y is equal to et then y exponent 4. And so here we have our n to be 4 and q of t to be e exponent t and p of t to be 113. And so we are going to have n to be equal to 4, q of t to be equal to e exponent t, and p of t is equal to 113. So now let's divide this guy through by y exponent 4. So we are going to have y prime on y exponent 4 plus 113y divided by y exponent 4 is equal to et y exponent 4 on y exponent 4. And so we are going to have this guy to be equal to y minus 4 then y prime plus 113 y minus 3 is equal to e exponent t. Now our next step is to take this guy as our z, right? So we're going to take this guy as our z, and so we are going to have z is equal to y exponent minus 3. Now we now differentiate this guy, so let's differentiate z. So z prime will be equal to, so we move the exponent, that's the power rule, then we subtract 1 from this one, so here's going to be minus 4. Then we differentiate y, so that'll give us y prime. That's, we are applying the chain rule in this case. Now let's find y prime, and so y prime will be giving us z prime divided by minus 3 y exponent minus 4, and this is equal to minus z prime on 3 y exponent 4. Now our next step is to substitute y prime is equal to minus z prime on 3 y exponent 4 into this differential equation, right? And so we are going to have y exponent minus 4. Now y prime, but y prime is giving us minus z prime on 3 y exponent 4. So that will be times minus z prime on 3 y exponent 4, then plus 1 on 3 y exponent minus 3. But y exponent minus 3 is z, and so here is going to be 1 on 3 times z is equal to e exponent t. In our next step, we have to simplify this guy. So here we have an index of base y and an exponent of minus 4, an index of base y and exponent minus 4. So we are going to add the exponents since they are multiplying. And so minus 4 plus 4 is going to give us 0, which is y exponent 0. So that's going to give us 1. So we are going to have just minus z prime on 3, then plus 1 on 3z is equal to e exponent t. And so let's multiply through by 3. So that's going to give us minus z prime plus z is equal to 3e exponent t. So now to get this guy in the form of a first order linear differential equation, the coefficient of z prime must be 1, right? So we have to divide through by minus 1. And so we are going to have z prime minus z is equal to minus 3e exponent t. And so we now solve this guy using the method of integrating factors. So we find our integrating factor mu of t, so which is going to give us e exponent the coefficient of z. So in this case, that will be minus 1. So here is going to be minus 1 dt. So that will be minus dt. And we are going to have this to be e minus t. And so our next step is to multiply through the differential equation by the integrating factor. So we are going to have e minus t multiplying z prime minus z is equal to e minus t multiplying minus 3et. And so the left hand side will always be equal to the integrating factor, which is e minus t in this case, times the dependent variable, which is z in this case. Then we differentiate with respect to t is equal to, so here we have e exponent minus t, e exponent t. So we are going to add the exponents. So minus t plus t will be 0. So that will be e exponent 0 is 1. So we are going to have here to be minus 3. Then we now integrate both sides. So we are going to have the integral of e minus t z differentiated with respect to t, then dt is equal to minus 3 dt. So the left hand side will be equal to e minus t z is equal to, then we have the right hand side to be minus 3t plus a constant c. And so we are going to have z to be equal to minus 3t divided by e minus t plus c divided by e minus t. Thus, we are going to have minus 3t e exponent t plus c e exponent t. And so this is our function z of t. But we have z to be equal to y exponent minus 3, right? And so we are going to have this guy to be equal to y exponent minus 3 is equal to minus 3t e exponent t plus c e exponent t. We can simplify this to get 1 on y exponent 3 is equal to minus 3t e exponent t plus c e exponent t. Thus, y exponent 3 is giving us 1 on minus 3t e exponent t plus c e exponent t. This question was an IVP. We need to find the constant of integration. So we have the initial condition to be y of 0 is equal to 2. And so we are going to have 2 exponent 3 is equal to 1 on minus 3 times 0 e exponent 0 plus c e exponent 0. So we are going to have 8 is equal to 1 on c. Thus c is equal to 1 on 8. Hence, our particular solution will be giving us y exponent 3 is equal to 1 on minus 3t e exponent t plus 1 on 8 e exponent t. We can take the cube root of y cube, so that's going to give us y is equal to the cube roots of 1 on minus 3t e exponent t plus 1 over 8 e exponent t. And so this is our particular solution to the above question. With our second question, we have to solve the IVP. Y prime is equal to 5y plus e exponent minus 2t y squared, and the initial condition is given as y of 0 is equal to 2. So let's rewrite this guy in terms of the Bernoulli differential equation. So we should have it to be of the form y prime plus p of t y is equal to q of t y exponent n. And so we are going to have y prime minus 5y is equal to e minus 2t y exponent 2. And so here we have our n to be equal to 2, q of t to be equal to e exponent minus 2t, and p of t to be equal to minus 5. So we are going to have n to be 2, p of t to be equal to minus 5, and q of t to be equal to e minus 2t. We need to divide through by y exponent n. So in this case, y exponent 2. So we are going to have y prime on y squared minus 5y on y squared is equal to e minus 2t y squared divided by y squared. So this simplifies to y exponent minus 2 times y prime minus 5 y exponent minus 1 is equal to e exponent minus 2t. So now we let this guy to be equal to z. So we are going to say let z to be equal to y exponent minus 1, and then we differentiate. So differentiating gives z prime is equal to minus y, then we now subtract 1, so that will be minus 2, then y prime. Then we compute y prime, so that will give us y prime is giving us minus z prime on z minus 2, which is the same as minus z prime z exponent 2. And so this is our y prime. So now we are going to substitute y prime is equal to minus z prime y squared into this given differential equation. And so we are going to have y exponent minus 2 times y prime, but y prime is giving us minus z prime y squared. So that's going to give us minus z prime y squared, then minus 5, y exponent minus 1 is z, and so here is going to be minus 5z is equal to e minus 2t. And so these two guys will go to 1, so that will give us minus z prime minus 5z is equal to e minus 2t. And so here we need the coefficient of z prime to be 1, so we just have to multiply through by minus 1. So that's going to give us z prime plus 5z is equal to minus e minus 2t. We now have our differential equation to be a first order linear differential equation where the dependent variable is z and the independent variable is t. So we solve this using the method of integrating factors. Find our integrating factor mu of t. So that's e exponent the integral of, so here we have the coefficient of z to be 5, and so that will be integral of 5 dt. So that's the integrating factor mu of t is e exponent 5t. So we multiply through this differential equation by the integrating factor, and so we are going to have e exponent 5t then z prime plus 5z is equal to e exponent 5t times minus e minus 2t. So the left hand side will always be equal to the integrating factor mu of t, which is e exponent 5t, times the dependent variable, which is z in this case, all differentiated with respect to t, is equal to minus e. So here indices of the same base, and when they are multiplying, we are going to add the exponent, right? So that's 5t minus 2t is going to give us 3t. So here will be e exponent 3t. We now integrate both sides with respect to t. So that will be integral of e exponent 5t z prime dt is equal to, we factor the minus out, and then e3t dt. So we are going to have e5tz is equal to minus e3t on 3 plus the constant of integration c. So now let's find z. So we divide through by e exponent 5t. So that will give us z is equal to minus e3t on 3, then e5t plus c on e5t. So this will be equal to minus 1 on 3 e minus 2t plus c e minus 5t. And so this is our solution z of t. But z is equal to y exponent minus 1. And so we are going to have y exponent minus 1 is equal to minus 1 on 3 e minus 2t, then plus c e minus 5t. So which is the same as 1 on y is equal to minus 1 on 3 e minus 2t plus c e minus 5t. Since this question was an IVP, we need to find our constant of integration c. So we have the initial condition to be y of 0 to be equal to 2. And so we are going to have 1 on 2 is equal to minus 1 on 3 e exponent 0 plus c e exponent 0. So that's going to give us 1 on 2 is equal to minus 1 on 3 plus c. That's c is equal to 5 on 6. Thus, our particular solution will be given as 1 on y is equal to minus 1 on 3 e minus 2t plus 5 on 6 e minus 5t. And which is the same as y is equal to 1 on minus 1 on 3 e minus 2t plus 5 on 6 e minus 5t. So this is our particular solution. With our third question on Bernoulli's equation, we are to solve the IVP y prime plus 4 on ty is equal to t cubed y squared. Then the initial condition is y of 2 is equal to minus 1 and t should be greater than 0. In this question, we have our differential equation already in the form of the Bernoulli's equation. So we are going to have our n to be equal to 2 and q of t to be equal to t cubed and p of t to be equal to 4 on t. Our next step is to divide the entire equation by y squared. And so we are going to have y prime on y squared plus 4 on t y on y squared is equal to t cubed y squared on y squared. Y minus 2 y prime plus 4 on t y exponent minus 1 is equal to t cubed. Let z to be equal to y exponent minus 1, then we differentiate. So that's z prime will be equal to, you move the exponent down, so that will be minus y, and then you subtract 1 from the exponent, so that will be minus 2, then you differentiate y. Now let's find y prime. So y prime will be giving us z prime on minus y exponent minus 2, which is the same as minus z prime y squared. Now we substitute y prime is equal to minus z prime y squared into our given differential equation. And so we are going to have y minus 2. Now y prime is giving us minus z prime y squared. So that will be times minus z prime y squared, then plus 4 on t. Now y exponent minus 1 is z is equal to t cubed. And so we are going to have minus z prime plus 4 on t z is equal to t cubed. So since we want this guy to be a first order linear differential equation, we need this coefficient to be 1, so we multiply through by minus 1. So that's going to give us z prime minus 4 on t, z is equal to minus t cubed. So we find our integrating factor mu of t, which is giving us integral of the coefficient of z, which is giving us minus 4 on t in this case. So that's going to be minus 4 on t dt. Integrating this guy gives then minus 4 integral of ln of the absolute of t, which is the same as ln of then t exponent minus 4. And so we have our integrating factor mu to be t exponent minus 4, which is the same as 1 on t exponent 4. With our next step, we multiply through the differential equation by the integrating factor. So you're going to have 1 on t exponent 4 z prime minus 4 on t z is equal to 1 on t exponent 4 times minus t cubed. So on the left hand side will always be equal to the integrating factor, which is 1 on t4, then times the dependent variable, which is z. Then we differentiate that with respect to t. Now the right hand side will be simplified to minus 1 on t. We now integrate both sides with respect to t, so that's going to give us integral of 1 on t exponent 4 times z prime dt is equal to minus integral of 1 over t dt. Thus, we are going to have 1 over t exponent 4 z is equal to minus then the ln of the absolute of t plus c. So we find z, so that will be z is equal to minus t exponent 4 ln of the absolute of t plus c t exponent 4. But z is giving us y exponent minus 1. So we are going to have y exponent minus 1 is equal to minus t exponent 4 ln of the absolute of t plus c t exponent 4. So that's 1 over y is equal to minus t exponent 4 ln of the absolute of t plus c t exponent 4. Now let's find our constant of integration. We had our initial condition to be y of 2 is equal to minus 1. So that's t is equal to 2 and y is equal to minus 1. So we are going to have 1 on minus 1 is equal to minus 2 exponent 4 ln of 2 plus c 2 exponent 4. We are going to have minus 1 is equal to minus 16 ln of 2 plus 16c. So now let's find c. So you're going to have 16c is equal to 16 ln of 2 minus 1. So c is giving us 16 ln of 2 minus 1 divided by 16. And so c is equal to ln of 2 minus 1 on 16. Thus, our particular solution is giving us 1 on y is equal to minus t exponent 4 ln of the absolute of t plus c, which is now ln of 2 minus 1 on 16 t exponent 4. And so y is giving us 1 divided by, so we factor t exponent 4 out, so that's going to give us ln of 2 minus 1 on 16, then minus ln of t. And so this is our particular solution.